is Theingi. I am a Master of Engineering Design student at McMaster. In this presentation, I'm going to talk about my project of creating a mobile application prototype using MIT App Inventor. Presentation outline is as follows. First, I'd like to explain my project inspiration and objectives of the project. And the next, I will explain what kind of user will be able to use my application. And then the user experience and interface of the application, because the design is the most important aspect of the application. Finally, I would like to explain the architecture and functionalities of the apps, where how data is being stored and read from the API, and also the functionalities and feature from each screen, and then what are the control structure, blocks, and sensor are utilized from MIT App Inventor to make these functionalities work. Art is not what you see, but what you make others see. I often get inspiration by exploring the great artworks, and I got the inspiration from this code, and I like my application user to discover thousands of great artworks and create their favorite collections by using my mobile application, and hopefully they also gain the inspiration like me. That is why I create the mobile application for exploring the great artworks from Chicago Art Institute. What kind of user will be able to use my application? For example, Julia, who is a creative art student, lives in Toronto, Ontario. She is curious about art and she wants to know more about the arts more than she already knows. She likes to color the specific art pieces, and she likes to understand and know more about the Asian artists and artworks, and she likes to save her favorite art pieces. Maybe she wants to buy them in future, but she has no time to go to exhibition and museum, and most of the time the museums are crowded. She likes a place or platform for her to explore the arts on her own space and then learn more about the artworks and artists. So Julia would be able to use my application for her objectives. Now, I like to talk about Art Institute of Chicago. Art Institute of Chicago has been founded in 1879, and the museum has more than 300,000 over hours, writings, and resources. And it is located at the Michigan Avenue, Chicago, United States. And the institute is one of the oldest and greatest museums in the world. The Chicago Art Institute of Education provided application programming interface called API for art lovers and developers to integrate and explore the great artworks to to their project like me by providing the public data. In the public data sets that they provide, there are 119,465 hours written, and for each hour, there are more than 50 attributes of the hour, such as year, artist, type of the hour, title of the hour, and etc. So this data can be consumed from the API endpoint. The API is at https:/api.artic.edu/api/v1/hours. My application utilizes API as the main source of the data. Beyond the inspiration of hours, and I like my application user to explore hours, I have the other project objectives as well, beyond meeting the project requirement for my assignment. I like to explore more about MID app inventor features through this application, and I like to develop commercial standardized application using the MID app inventor. And I also like to learn more about limitation and challenges of using the MID app inventor if I were to create the commercial standardized application. That is why I decided to consume their such a huge data source API to explore the hours using the MIT App Inventor. Next, I would like to talk about the user experience and user interface design of my application. The design is very important step of the creation of the application. In terms of the I utilize the two primary color. The first one is the reddish color of the same color as Chicago Art Institute. In this way, I can provide the great credit for the institute, allowing the developer and like me to utilize the data and explore the great artworks. And the second primary color is a black color because I like to use black color to help to stand out the hours. Black is the natural color to help to stand out the hours. In terms of the user experience, I use the major experience that user will have is the smoothness of the browsing the application. Most of the mobile application use the navigation button on the screen itself because this will take up the application space and then it will destroy the artworks. So that is why I utilize a cyber navigation where user can navigate through the screen of the mobile application. The second important aspect of the application is the architecture for the functionalities. My application requires user to log in and then explore about the Chicago Art Institute and artworks and also view their artworks by their favorite and desired keywords. So for that purpose, I need to utilize a database called Firebase where when user log in or register, the data is being stored and verified through the Firebase real-time database. Firebase database, real-time database, I've created the two buckets. One is for the accounts information and the second one is for the award collections. So when user is verified through the Firebase in the application, user will be able to see the awards and data are coming from the API endpoint. I've utilized the two primary API in the application. The first one is the primary/award endpoint, where the API return all the latest hour. For the demonstration purpose, I limit to the 100 hours for this application, although there are hundreds of thousands of hours available through this API. But it's not limited to 100. In my application, I allow user to search the artworks by their desired keywords. For that purpose, I use the API endpoint called /search, where user will type their desired keywords such as Japanese, Canada, village, and such, and then application will go and read their data from this endpoint and return the artworks back to the user. This is a major architecture of my application. My application includes 6 major screens. The first one is initialization. Once user open their application, user will see their apps names and then the version of the application because mobile application usually require to update the version because of the mobile OS nature of the upgrading or is any upgrades require user is well informed about the version. So that is why I provide the initialization screen. Once the screen has been initialized, user will be routed to the login screen. User will be able to log in, or if they do not have the account, they can register. And the third screen, user will be able to learn more about Chicago Art Institute, view the video of the great institute and museum, and feel about how great the museum itself. And then the fourth screen is where user will be able to explore the hundreds later hours collection from the institutes. And the fifth screen is where user is able to search the artworks by their desired keywords and then save those search results in their collection. So the final screen is the collection screen. As part of the project requirement, I like to explain what are the MIDF inventor blocks utilized for each screen. So for initialization screen, I have to use only one control structure but use the clock sensor to initialize the screen. For the login and registration, I use 14 control structure, 1 variable and 2 custom procedures. And then I use Firebase database to save and retrieve the data and notifier for the phone validation and extension for the cyber navigation. And then that screen of About Institute, 11 control structure, 1 variable, 1 custom procedure is utilized. For this screen, I have to use a video player for user to view the video of the institute directly in the application. For the latest hour collection, there are 13 control structures, 7 variables, and 1 custom procedure. In this application, Web2 components required to read the JSON data from the Chicago Art Institute API endpoint. And then such screen, 16 control structures, 8 variables, and 1 procedure has been utilized. And in this screen, all the great component like Firebase Web2 Notifier extension has been utilized. And then final screen is about my collections where users see or their safe hours. And in screen, I've utilized 10 control structure and 4 variables. Now I like to switch my presentation to the MID app inventor. So here is the number screen that I have. Screen 1, search my collection, login, landing, and collection. For example, for screen 1, which is the initialization screen, there is only one control structure, and then clock timer is utilized. For example, for landing page, which is about institute, there are multiple control structure and variables are utilized. Okay, now you got the idea that how the control structure and variable has been created in the MID app inventor. Now let me go back to my presentation. Okay, next, I'd like to briefly mention about what are the challenges that I face while I develop this app. So when I'm using the iOS application, the MID app inverter Web2 coordinator to read the data from the API endpoint is not working. So I have to use the Android application to download this app. And the second challenge that I feel is that I like to play video directly in the application, and the MID app inventor provide the video player.start function out of the box, but this function does not work. I have to utilize the clock timer to start the video when user open their screen. So I mentioned because it took me time to troubleshoot and discover the issue. And then the next challenge I face while developing this app is that the convenient app disconnection happened so many times. I have to reconnect for continuing my development. That takes effort. That affect my productivity of the development. And these are the references of my application. I like to show my Firebase database structure. This is a Firebase database I created. It's a real-time database, and database include two buckets. One is account. I have now 3 accounts, and one is the collection, which is created under my account. And then I like to show the API endpoint. This is the endpoint that I have used for the latest hours, which I limit the 100 hours collection. If we see here, there are thousands of hours exist in the API, but I limit only 100. And these are the feeds that I retrieve from the API. This is a custom API endpoint. If we don't limit anything or any field, the API default endpoint will return all the data, which is more than 12 pages, more than like 9,000 pages and more than 50 over attributes for each hour. And then another API endpoint that I use is the /search endpoint, where user will be able to search the hours by typing the keywords. Next, I will show you my MIDF Inventor creation screen. There are 6 screens that exists for my application. The first one is this screen 1, which is the initialization screen. Then this is a control structure that I use. And then I have landing page, which is the about institute page, and collection page, which is the latest hour collection, search page, which is the search screen, and then login screen, and then finally the my collection screen. So each screen has all the components that I utilize here, and I've also named the components in the proper name so that it's a best practice, and then when I have to download or change or modify, it is easier to maintain the application. Next, I like to demonstrate the full application as an end user. User open the application, user will see the initialization screen with the name and the version, and then user will be able to see the login screen where user can log in, or if they do not have the account in prior, they can register. So click register, and the screen will ask for the username and password. If user do not enter any information, the screen will tell the user to create the account. So now I will create the account, go and then password is 12345, and then save. So registration is now successful. Now I can log in. Now let's try. I want to create another account using the same username AAA, and I submit. So the app will tell you username is already in use. I cannot create another account with the same name. So now I go back to my login screen, and then I will use my account, which is I create before, and if I don't enter password, the screen will prompt me to enter the password. If I enter the wrong password, the app will say incorrect username and password. So now I have to enter the correct password, 12345, submit. Okay, once the user is logged in, user will be able to see the Chicago Art Institute about page. So the video is a great way to learn about the institute. Okay, for the demonstration purpose, I will view the video till the end. Let me switch to the another screen. So another screen, user is able to click the menu on top, and then user now wants to see the latest hour collection. Now I'm as a user, I'm able to view all the latest hour. See, I can see all the hours So library grade hours, type there, and then type, and then artist name. So there will be 100 hours in the application. As I mentioned, there are thousands of hours that we can view, but for the demonstration I only retrieve the 100 hours. And then now I want to search the hours by my desired keyword. So I click search, or I can go to the navigation and I click search. Here I want to explore the earth of the Japanese. I type Japanese and I click search. So it will take a while to read the data, and then I get all the words related to the Japanese keyword. So in terms of demonstration, I limit only the 10 hours for the search data. So for the actual application, if I don't limit anything, so the apps will return all the hours related to the Japanese keyword. Now I want to view this hour in the bigger font. So if you click, and then I have the same experience of viewing their hours, navigating through previous and next. Okay, now I like to save this Japanese hour to my collection. I click save this collection. So if I save this collection, so the data will be saved in the Firebase database, and then now go to my view my collection, where I'm able to see all my saved collection. And I hope you enjoy my application, and thank you for your attention and time.